We've talked about elastic collisions where things bump together and bounce apart. We've talked about inelastic collisions where they bump together and stick together. This time we're going to kind of go backwards. We're going to say it's going to explode, right? So we're going to make one thing change into many things. Okay. So our learning target is I will analyze explosive collisions by applying the principles of momentum conservation and system interactions, using mathematical models and experimental data to explain how objects move apart after an explosion. Okay, so like I said, explosive collisions are basically inelastic collisions backwards. Okay. They happen when one object splits into two or more pieces and then they move away from the original location. So if you look at our picture, we have the before, these are like stuck together, or they could be all one thing, right? And then they explode, right? And then after, they are their own piece, right? They have their own mass and they move in a direction. It could be any direction, really, but we're going to right now focus on just one dimensional. Okay. Our equation is just the backwards from the inelastic collision. So instead of starting with M1 V1, we're starting with M1 plus M2 times U2. Okay. A lot of times the U is going to be 0. The only time it's not is if they say that it's already traveling at a specific velocity, right? But most of the time it's going to be 0. Okay. That's going to equal the mass of the first one times the velocity of the first one, plus the mass of the second one times the velocity of the second one. Okay. During an explosive collision, the energy will not be conserved. Make sure you write that down. You probably don't understand what that means just yet. Okay. So, explosive collisions in one dimension resemble an inelastic collision only backwards, and pieces move in the same plane. That means that there's no angles. Okay, so for example, I have two carts that are attached to each other with a compression spring in between. So, you've got the two carts, and then, one of the springs pushes, and the carts move in opposite directions when they let go. Okay, sample problem, a cannon. So we have a cannon of mass 400 kilograms, and it's going to fire a shell, right, like a cannonball type shell of mass 20 kilograms. If the shell leaves the cannon at 300 meters per second, with what velocity does the cannon recoil? So if you've ever seen movies or, any time that a cannon goes off, you'll see that the cannon will go off and it will push its shell or cannonball forward, but the cannon itself will actually recoil backwards. You'll see it move backwards. So we start with the cannon and the shell together. At this point, it's not moving. Okay. Then after the cannon is fired, the cannon moves backwards. The shell or cannonball moves forward. They want to know what is the velocity of the cannon while it's moving backwards. Okay. All right. So, step 2, write the correct equation for solving this problem, E, right? So the E step of guess is to write down the equation. Don't put any numbers in it or anything, just write the equation. Okay. The third step is then to fill in your known values. If you write this equation out and then go back and fill it in exactly the way that it appears, you will make it so that you don't have things in the wrong place, put it that way. Okay, so we're starting with 400 kilograms of the cannon plus 20 kilograms of the shell. moving at 0 degrees. Sorry, 0 meters per second. Okay. Afterwards, I have the cannon, 400 kilograms, times the velocity of the cannon moving backwards, plus the 20 kilograms of the shell times the 300 meters per second that the shell is going. Okay. Next is just use the algebra to solve. So that beginning number becomes 0 because 0 times anything is 0. And then we have 400V plus 6,000 kilogram meters per second. Okay. I'm going to try and get the V by itself. So 6,000, I'm going to subtract 6,000 on each side. That leaves me negative 6,000 on the left-hand side. Okay. And that's going to equal 400 kilograms times V. Okay. Then to get V by itself, again, divide by 400 on both sides. And you'll end up with V is negative 15 meters per second. Okay. So what is this telling us? Okay. So does the answer make sense? We have a negative 15 meters per second. Okay. So 400 kilogram cannon moves backward at 15 meters per second. That's what the negative sign means. So that makes sense, right? The cannon's going to go the opposite direction as the cannonball. Okay. 400 kilogram cannon is slower than the 20 kilogram bullet. That makes sense, right? The bullet has a lot less mass. So this is going to move faster than the larger mass. Okay. Cannon moves backward, bullet moves forward. Okay. So yes, it makes sense. Okay. But in real life, right, the original object explodes to form two or more pieces that move at angles away from the center location, right? When something explodes, we usually expect that the pieces are just going to go outward from the center, right? Which means that that there's 2 dimensions, maybe even 3 dimensions to that problem. Okay. Again, we're going to use our X and Y components. They're still conserved, but they're still treated independent of each other. Okay. So that means that the momentum in the X direction, right, and the momentum in the Y direction are independent of each other. Okay. Therefore, a momentum conservation equation would be calculated in both the X and the Y dimensions. Then they're combined to find magnitude and direction of each object, right? So for each object, you're going to find an X component and a Y component. And then in the end, you're going to use Pythagorean's theorem to solve for the actual magnitude and direction of that particular piece. Okay. So to sum it up, explosive collisions happen when one object splits into 2 or more pieces that move away from their original location. Okay. The equation for collisions is m1 plus m2 times the beginning velocity equals m1 v1, right, the momentum of the first object, plus m2 v2, the momentum of the second object. And then if there's more than 2, plus the momentum of the third, plus the momentum of the fourth, etc., right? Explosive collisions in 2D, the original object explodes to form 2 or more pieces that move at angles away from the center location.